Hey everybody, this is Gregory from Dapp University, and today I'm going to be showing you how to use the Web3.js library. And this is the main JavaScript library for interacting with the Ethereum blockchain. I'm going to show you how to use Web3 to interact with smart contracts on the Ethereum blockchain. So check out the previous videos in this series for an overview of what Web3 is and how it works. But it's not necessary. You can just kind of jump into this video and follow along, and you'll probably have a good idea of what's going on. And once these videos are done, I'm going to post them to my website with some code examples so that you can have those for reference over at dappuniversity.com. And you can also follow me on Twitter for daily updates as I'm creating this series. And also be sure to subscribe to this channel and turn on notifications with the bell below to see the next videos in this playlist when they come out. So this video is, designed to teach you how to use Web3.js, which is, one half of the equation when you're developing decentralized applications. There's smart contract development, which is code that's going to get written and deployed to the Ethereum blockchain. And, the other half of the equation is interacting with those smart contracts with JavaScript with some sort of client. And that's what we're talking about today. So today we're going to use Web3 to create, a way to talk to a smart contract. And we're going to read some data from the contract and, kind of see how you can do that. So if you look at this documentation here, this is web3js.readthedocs.io. This is how we're going to actually, create a way for Web3 to talk to a smart contract. It does this with this web3.eth contract here. And essentially what this does is it creates an abstraction of our smart contract in JavaScript that we can use to, call the functions of the smart contract. Now, smart contracts are written in Solidity on the Ethereum blockchain, which is, a completely different programming language than, JavaScript, obviously. And they get compiled down to bytecode that's executed on the Ethereum virtual machine. And, if we want to actually be able to, interact with that smart contract on the Ethereum virtual machine on an Ethereum node, we must know, the interface of the contract. We must know what kinds of functions it actually has, and we must know, what functions we can call and what we can actually do with it. And that's exactly what we'll do with this, ETH contract here. We're going to create, a representation of the contract in JavaScript, and we will, use its functions. And we'll do that like this. So let's just kind of look at this documentation here for a second. What we're going to do is create a new Web3 ETH contract. And this is saying that we need to give it a JSON interface and an address. And these are the two kind of components that are critical. So a second ago, I said, we need to know what the interface of the contracts looks like. We need to know what kind of functions it has. And so essentially what we can do is get something called an ABI. Now, an ABI is essentially just like a JSON file that shows you what a smart contract can do. It's going to show you all the functions that it has. It's going to show you lots of different information about it. So I'll show you an example. You can actually look at this here. So here's an example of a contract ABI. It has some information about the smart contract. This is called election. This is actually a representation of a smart contract that I actually built out in a longer tutorial that I have on this channel, where I show you how to build your first decentralized application on the Ethereum blockchain. You can check out that video if you'd like. And so this is, a JavaScript JSON representation of the smart contract that shows you, the kinds of things that it responds to. Shows you the bytecode for the contract. So I don't want to get too bogged down in this. I just want to show you that this exists. And this is, like the Solidity code that corresponds to the JSON ABI. I teach you how to build this Solidity code in my other tutorial if you want to check that out. All right, so that's the first thing. So we need a smart contract ABI when we actually want to talk to a smart contract on the Ethereum blockchain. We need that big old JSON file that I showed you a second ago. And we also need to know where the contract is located. We need an address. So if you're new to, Ethereum development, and you checked out maybe the previous video in this playlist, everything that's connected to Ethereum has an address. So You as a user that's connected to the Ethereum blockchain, you have an address that represents your account, and also smart contracts that are deployed to the Ethereum blockchain also have addresses. And this just basically tells you, where the smart contract is located. And that's essentially what we need here. In addition to the interface that tells us how the smart contract works, we need an address to tell us where the smart contract lives. So we'll get both of these pieces of information whenever we create this new smart contract in JavaScript to interact with. And what I'm going to do is connect to the main Ethereum network, and we're going to actually read a smart contract that is deployed to the main Ethereum network and read some real live data to show you how that works. And also I should note that, if you watch my previous video, I kind of compared, talking to the Ethereum blockchain and the smart contracts on the blockchain and all the nodes on the Ethereum network. I kind of compared that to like talking to, API maybe, like if you were coming from a traditional web development background where you have, a JavaScript client that wants to talk to an API in a similar way. We're going to use, a JavaScript environment to talk to smart contracts on the blockchain. The blockchain is going to be essentially our back end in this case. So we're going to try to, call some functions that might be kind of like endpoints on a back end or something like that. It's not a perfect analogy, but it gives you an idea of what we're going to do. And what we're going to do is actually talk to a token contract on the main Ethereum blockchain. We're going to talk to, a token that was, minted and went through an ICO, and basically distributed across the blockchain. So Ethereum has a way to implement tokens with the ERC20 standard. ERC20 is just a standard that specifies how the tokens work, and it specifies a common interface so that all the tokens work the same way, so they can be like listed on exchanges and bought and sold that way and transfer between wallets in a predictable fashion. And this is called the ERC20 standard. You can read more about this if you'd like. I go into this more in depth in some of my other videos where I show you how to build an ERC20 token. And you can see that there's some functions this token responds to, like the name. You can read the token's name. You can read the token's symbol, like you'd see on a cryptocurrency exchange. You can read the total supply of the tokens, and you can read the balance of somebody who owns the tokens. And these are some of the kinds of functions that we'll run through today whenever we interact with this smart contract with Web3.js. So let's go ahead and get started. First, you want to go to your terminal, and you want to ensure that you have Node.js installed. You can check that by going node-v. And you also want to ensure that you have the Web3.js library. You can install that with npm install web3. I've already done this, so I'm not going to do it again. Once you've completed both of those steps, we'll go ahead and open the Node console like this. Just type node and enter. And the first thing we want to do is require the Web3 library. We'll do this with uppercase var web3 equals require web3. All right. And what we want to do now is get an actual instance of web3. We say var web3 equals new capital web3. This is lowercase, this is capital. And what we need to do is pass it a URL for an Ethereum node. Now, I talk about this more in depth in previous videos, so check that out. I don't want to belabor the point in every video, but essentially what I'm doing is creating a connection to the blockchain, and you'll need a URL for an Ethereum node. You can run one locally, or you can use a remote node with something like Infura. So check out that first video if you want a greater explanation of what's going on here. All right, now let's just ensure that our connection worked. We can kind of see, yeah, looks good to me. All right, so what we want to do is actually, create an instance of this smart contract in Web3. We want to create a JavaScript representation of that. And, a moment ago, I said that we need, the smart contract ABI and we need an address. And what we want to do is actually, read a smart contract on the main Ethereum network. We want to read a token. So let's go find a token that we can actually use and interact with. So what I'm going to do is pull up Etherscan. So Etherscan is a blockchain explorer that lets you, read all kinds of data on the Ethereum blockchain. You can find smart contracts and, accounts and look at transaction histories and blocks and things like that. So I'm going to find a real token by going to this Tokens tab and going to View Tokens. We'll choose a pretty popular token. Let's say OMG. So I'll click on OMG here. And, like I said, these tokens are smart contracts that are written with this ERC20 standard that I mentioned a moment ago. And what I can do is I can actually get some information about this on Etherscan because it's publicly available. I can essentially click on the contract address here, and it's going to give me a way to look at the code of the smart contract. I can actually see the Solidity code here that implements this ERC20 interface. And I can also get this smart contract ABI, which is the thing I talked about a minute ago. This is going to tell Web3 what the contract does. So I'm going to copy this, and I'm going to go back to my terminal. And I'm going to say ABI, or var ABI, equals this ABI. So I'm going to just paste it in. Hit enter, ABI. All right, so this actually gave us the JSON. We can see that was formatted nicely for us, so we can tell what's going on. Again, if you look at this ABI, you can see that these are names of functions. Name, it's a function. It tells you right there the type. This is the total supply, which is also a function. You can see that there. You can see, mint, paused, balance of. That's one we'll use in a moment. This is also a function. So that kind of just shows you what's happening with this ABI. Now we want to tell Web3, we need the address. And that's pretty easy. We can just go up here to this address and click copy. And go back to our terminal and say var address. Paste this in. All right. Now that we have both those things, we can read some information about this. Actually, let's rename this variable. Let's say contract address, because what we want to do is get a account address momentarily. Yeah, oops, looks like I had a little typo there. My fault. So yeah, what we can do is get a connection to the smart contract with Web3. So we'll do that like this. We'll say is var contract is going to equal, let's be new web3.eth.contract, and we'll paste in the ABI that we stored to the variable in the terminal, and we're also going to pass it the address. This will be the contract address. Oops. Looks like I put too many S's on the last end of that last one. That was why. Okay. Now we can see that we've got an instance of this contract. And we know we do because we can say, we can actually call a function on it. What we'll do is see if we can get the name. We'll do that like this. Tract methods. We can actually see the list of the methods that were created by the ABI. The ABI basically told us what functions this contract responds to. So we'll actually see that it responds to name. This will give us the name of the token. We could say methods name, and this is actually going to just return the actual function that is name. It's not going to call the function. So we must call it like this. We must say call. And in order to get the value, if we, this is just going to return a promise. This won't actually return the value because this is an asynchronous call. So in order to actually read the value, we must pass it a callback function. And we do that like this. We just pass it a function. Just sketch this out. And it's got a couple of arguments. The first argument is an error, and the second argument is the result. And let's just console log the result. We'll say result. All right, there we go. We can see the contract name was actually returned to us. This is OMG token. This is the actual OMG ERC20 token that you see all over the place, bought and sold on cryptocurrency exchanges, listed in coinmarketcap.com. We're actually talking to this token on the Ethereum blockchain, and we've just read the name. We can also see, some other things that we can do. Track methods. These are the other, functions that exist in the smart contract provided by the ABI. Let's just say, let's read some more data. We can say, you can see the symbol right here. This will be like, what's on the cryptocurrency exchange. Let's just edit this. All right, OMG is the symbol. And let's also look at the, let's see here. Let's look at the total supply. This is going to tell us, how many OMG tokens actually exist. Let's say, boom, there you go. That's a really big number. We can also say, I believe you can see if minting is finished to see if all the tokens have actually been minted. I believe I saw that somewhere. Yeah, minting finished. Yep, it's true. So all the tokens have actually been minted and the supply won't change. So now what we want to do is actually read some more specific information from this contract. ERC20 tokens allow you to read the balance of people who hold specific tokens, and that's what we'll do next. We'll essentially, we're going to create, we're going to do balance of. We're going to call this function. This exists. This is a balance of right here. This is a function that allows you to read the balance of someone who owns it. And essentially, this is going to take an address, which we can see here. We can see the list of arguments that these functions accept whenever you call methods. So balance of address, right? And we say contract methods balance of. So we need to actually paste the address in. So I'm going to hit enter, but this is not going to work. All right, it's going to give us an error. It says invalid number of parameters. So we need to give it an address. So what we want to do is assign an address to someone who holds these tokens. So we'll say var account address. We'll actually need to paste an address in here. So how do we find an address? How do we find someone who holds these OMG tokens? Well, if you hold OMG tokens, you could put your own address in there, or I could put my own address in there. But for this example's sake, let's find someone who owns OMG. So go back to Etherscan and find this page that shows you the smart contract. And I'm going to go back to the token page, and the token page is actually going to show us as a tab that shows you token holders. And this is, I believe, ranked by quantity and percentage. You can see the percentages of people who own these tokens. So let's click on one of these. Let's just click this address here. We'll see who this is. So it looks like this is actually a smart contract. Yeah. So one thing to notice is that, like I said, smart contracts have addresses and accounts have addresses on the Ethereum blockchain. And, you and I, as users of the Ethereum blockchain, can hold tokens, but so can smart contracts. And that's exactly what is going on here, I believe. It looks like this is a holder, but it's a smart contract. And I'm going to copy this address and minimize this. So this is technically an account. It's just a contract account. And what I'm going to do is type in balance of address. All right, there we go. and we can see the balance of how many tokens this particular account actually holds, which is a lot of tokens. If you go back to Etherscan, you can actually see what that's worth. Looks like, $41 million. So it's a lot. All right, so that's an overview of how you can use the Web3.js library to talk to smart contracts on the Ethereum blockchain. And today, we talked about how you can read data from smart contracts. You can do a lot more with the Web3.js library, like, actually writing data to smart contracts on the Ethereum blockchain. You can, deploy smart contracts. You can do things like that. And yeah, you can compile smart contracts and do all kinds of stuff. So today, I'm going to leave it at that, but I will be making more videos about smart contracts in the Ethereum blockchain. So be sure to subscribe to this channel and turn on notifications with the bell below to see the next videos in this playlist whenever they come out. And until then, thanks for watching Dapp University.